AB Calculus Note Card 51, Area Under a Curve. This is the 51st lesson in the series inspired by Stacy McMullen, formerly of Dallas Independent School District, who developed the note card system. If y equals f of x is a non-negative and integrable over a closed interval, that closed interval being from a to b, and so we're looking at a function that would be above the x-axis somehow. Okay. And is given by the area of the integral from a to b of f of x dx. This region bounded by the x-axis and the vertical lines x equals a and x equals b, and is always positive. And so here we have, in this little drawing up here, a and b, points a and b, we have a vertical line proceeding up from A and also up from B, and it's going to be the integral from A to B is going to be this area under the curve. However, a definite integral of an integrable f of x can represent other fields: profit, loss, water consumption, entrance, exit into a store, and can be a positive or a negative value. And here we have a broader definition where we have the integral from a to b of fx dx is the area above the x-axis minus an area below the x-axis. So we're going to get to that in a couple example problems here. The first of which, set up a definite integral that yields the area of the region denoted by f of x equals the square root of quantity 9 minus x squared. You may not realize this right off the bat, but this is going to be the function represented by a semicircle. And I'm going to show you right here. If you have the general form of a circle, x squared plus y squared equals r squared, and r being the radius, y squared is equal to r squared minus x squared, and so y is going to be equal to plus or minus the square root of r squared minus x squared. And in this case, we have f of x equals the square root of 29 minus x squared. So we're going to have y is equal to plus, and 9 is equal to 3 squared minus x squared. And what we have for the plus or minus is going to create the plus will be a semicircle above the x-axis, the minus will be a semicircle below the x-axis. And so this demonstrates that we have a semicircle with a radius of 3. And so this is what the thing is going to look like. If we have a xy coordinate plane here, xy, and we have a semicircle with a radius of 3. So we're going to say our a value here, the integration, is going to be negative 3, b value is going to be 3, and then we're going to have this shape up here like this. Now, you remember it said, the last thing we looked at here, the area will be above the x-axis minus area below the x-axis. Well, here, what we have is a non-negative area, and so we're going to have this area that I'm now hashing in here, which is going to be, area is going to be pi r squared, and since we have a semicircle, we're going to be dividing by 2. And our radius of our circle is going to be 3, so we have 3 squared divided by 2. So we say area is equal to 9/2 pi. So that's our area. And again, we had to have an understanding of this, what type of shape this is, to work out this problem. Yes, this is integrable using the function through trigonometric substitution, but we're just going to leave it here today. And that's that one. Next, 2, in the linear piecewise function f to the right, f has the given points and is defined by the interval from -2 to 3. And here we're talking about a closed interval from -2 to 3, and these values become our A and B respectively. Okay, and what we're going to have is our area above the x-axis, which is this triangle right here. So this is going to be our positive. And then we have this area below the x-axis right here, this trapezoid. So we'll say negative area. And so we will say this is equal to, area of a triangle is equal to 1/2 base times height. So we're going to have 1/2, and our base is going to be 1, 2, 3.5. So I'll say 3.5. And our height is going to be 3. And then we're going to subtract out this area of a trapezoid. The area of a trapezoid is going to be height times base 1 plus base 2 divided by 2. So let's go work that out. We have our height is going to be 1 unit times base 1, and base 1 will be 1.5, and base 2 is going to be this value of 1 here, and we're going to divide that by 2. And then if we simplify this, we're going to get 10.5 divided by 2 minus, we're going to have 2.5 divided by 2, and that's going to be equal to 8 divided by 2, which is going to be an area of 4. So we say area, it's not the area, we will say integral from -2 to 3 f of x dx is equal to 4. And is that the case here? Yeah, we got over 4 here, but we're subtracting out this area here, so that looks about right. Anyway, this is the general concept of how to look at it. We're going to get into more detail later. I hope this has been helpful to you. Good luck, and thanks for viewing.